Hey there, Dave Brennan with another instructional video. This time I'm talking about how to use a multimeter in regards to testing on pinball machines. This is a very inexpensive multimeter that you can get off of Amazon for around $15 to $20, and it's going to have all the functions that you really need as a pinball hobbyist. The major ones that you're going to use are voltage, resistance, and continuity. So the first one I'm going to cover is DC voltage. So every pinball machine has AC power that comes in from your wall outlet, and then it goes into a power supply that converts it to DC, and depending on the game, it will have several different voltages that it uses, so consult your manual to know what those are. On this particular game, there are 3 different voltages that the game runs on. It is a 5 volt, 12 volt, and 48 volt. Individual power supplies that are in this big metal box in the back of the cabinet. Now, to measure those, you're going to take your multimeter and you're going to set it on the V with the solid line with dots below. That is DC voltage, and you want to set your dial to, so for example, if you're measuring 48 volts, you want to set it to something that's higher than 48, and that will work for your 5 and 12 volt measurement as well. So if you want to get the measurement directly from the power supply box, what you're going to have to do is the 5 volts is a red and black wire, so red for positive, black for negative. 12 volts is yellow and black, and 48 volts is brown and black. So I'm going to just show you, for example, on this top plug here, and I can see I have yellow and black wires. So you can just take your probes, and you see where the wires go into the connector. You want to push the probe into the back of the connector, and there's little metal pins crimped onto the wire, and that's what you're going to be touching in order to get your voltage. And so when I plug my probes into the back, you can see that I'm getting 12 volts for the yellow and black. And you can do that for any of the voltages that you want to measure directly from the power supply. Now, that power supply might not be easiest to get to depending on the game, and so where's an easier spot where I can measure this voltage? So in this case, let's focus in on 48 volts. 48 volts is, in this game, is exclusively used for the powering coils. And what it does is the 48 volts positive goes directly from the power supply and goes to the interlock switch that's located at the bottom left-hand inside corner of the coin door. And you have these spade connectors on the back side of the switch, that it's a make-break switch. So meaning when the door is closed, this tab pushes in on the switch, and the power runs through the switch. Same thing if you pull out on the interlock switch, it will send power. So that's what you would do for testing coils when you have the coin door open. So in order to test this, this is essentially coming right from the power supply, so you don't have to get all the way in the back of the cabinet. Take your black lead, and there's a metal ground strap on the side wall of the cabinet. Just put your lead behind the ground strap and that will give you connection. Now take your red lead and touch it to the metal tabs on the spade connectors where they get connected. And it should be, with the coin door open, one wire is going to show no voltage, and then the other is going to show 48. That means that, or in this case it's very low. So 48 volts on one, and then it should be close to 0 or 0 on the other, meaning that voltage is not going through this switch in the rest position. Now, when you either close the coin door or pull out the interlock switch, you can see that you should have 48 volts on all of the wires plugged into this interlock switch. And that's telling me that the power is getting through the interlock switch, and now it's going up to the coil driver board on the playfield. Now, before I show you the playfield, while I'm in here, I'll show you a couple other spots where you can measure voltage from. This is a yellow and black for 12 volts. This is going to the coin door. So again, you just put your probe into the back side of the connector and touch the metal pin, and you should have 12 volts power there. And then the other voltage that I talked about was 5 volts, and you have your P-Rock board on this side wall of the cabinet, and you'll want to again probe in the back side of the connector to get the 5 volts reading on your multimeter. Now, with your playfield lifted fully vertical, you can see the coil driver board that's right in the center of the playfield. It's the longest board, and this is what drives all of your coils. And you have two different banks of coils that it drives on each. This is a multimorphic PD16 coil driver board, and so in this case you have a left and a right bank, and on both the left and right hand side of the driver board you will see a clear plastic case that contains a fuse for getting power to this board for 48 volts. So currently I have the coin door open, so it's not supplying 48 volts to this board quite yet. It actually goes, the 48 volts actually goes to this capacitor board first, and it has an in and an out, and then it connects to the coil driver board. So that's another path there. And then once it goes up there, then it supplies this board. And what you're looking for when you power up the game, you're going to see on the right and left hand side of this board that there are two red LEDs on the very right and left, closest to the largest connector plugs of the board. So I'm going to push the interlock switch and show you the lights that light up. And you can see if those lights are lit, that means you have 48 volts going to this board. If they're not lit, then that either means you have missing voltage further down the chain, or your fuse is blown. And again, with the game, I'm not going to do this now because the game is powered on, but this is the fuse cover. If you want to this just pulls right up, and then there's a fuse clip with it's a 5 by 20 millimeter slow glow 6.3 amp fuse for this particular game. Okay, now let's move on to connectivity. This is helpful in finding out if you have a connector that's not giving good connection or a switch that's not working properly. But it's a very useful tool. And so you can take your dial on your multimeter and you want to put it all the way down to connectivity or diode test. On this particular game, it's like an arrow with a plus sign at the end, or a little kind of speaker indicator there. But basically, all you want is when you touch your probes together, it's going to give you a beep showing that you have connectivity. And in this case, I'm going to talk about the interlock switch again. Now I have the game powered off. But this is really just to test that you have connectivity going from, so when you push in or pull out this interlock switch, it completes the circuit and sends power up to your coil driver board. So in this case, you want to put the probe on both tabs that the brown wire is connected to, and you want to push in on the switch, and that's telling me that at least this top one, because I have 4 wires here, the top and bottom, but that top one is working well. Same thing, repeat this on the bottom. Oops. You repeat this on the bottom, showing that that switch is working well. It'll do the same thing when you pull out on the interlock switch and then you touch those 2 tabs. You should have connectivity going through the switch showing you that that works. Here's another example of connectivity, just the simple tilt bob. So how this works is it's completing a path to ground. So you have a switch wire that's connected to the tilt bob rod and the weight, the pendulum weight. And so when you touch the 2 connections, since it's not touching the ring now, you have no connectivity. But this is the ground strap, so this is another spot where I can show you. So when I move this tilt bob over and touch the sidewall, now I have connectivity. So that's just another way showing you how that works. Same thing if you were trying to find if there was like a break in a wire somewhere as you're troubleshooting. You could actually, as I explained, the power path of 48 volts going from the power supply to the interlock switch up to the capacitor board to the coil driver board, you can check those wires all along the way using connectivity. Make sure that you have a good path up to the top. All right, so that's connectivity. The next one, we're going to go and use resistance, and the only time that you really use this is for testing coils. So in this case, the resistance is the omega symbol on the multimeter, and you want to set this to typically coils, unless it's a really high resistance coil, it's going to be, you can use the 200 setting because it's going to be a fairly low resistance value. So in this case, let's take a look at a coil up here. Now again, this is with the game powered off. You don't need any power going to coils in order to test their resistance. So this happens to be a 23 by 800 coil, and so you can unplug the Molex connector. This would lead to your coil driver board, but you take your probes and again touch the metal pins on the inside of the plug, and you will get around 4.6, 4.8 ohms, showing that that is a good coil. You can do this all through the game. Here's another coil that is a 26-1200. You just unplug the Molex connector again, and you can probe those pins to get 11 point. To get about 11 ohms. So you can do that. Typically on pinball machines you have more than one coil that is of the same value in the machine. So you can, if you don't know what the resistance value is supposed to be, you can compare one coil of the same color with another color. Or if it depends on what's written on the wrapper of the coil. So now let's talk about flipper coils, because this is slightly different because they are dual wound coils. So I happen to have a flipper coil right here. You can see that it has 3 leads going to it, and so in this case you have your power going in is the solid black wire, and then you have a black with a white stripe and then a white wire. And dual wound coils have 2 resistance values. One is going to be a low resistance for basically your power stroke, or when you first hit the flipper button, and then you have your hold power, which will be a high resistance. So as you hold the flipper button in, it doesn't burn up your coil when you sit there and hold it. So take your black lead, or any lead really, and you touch the black wire, and then you do the center pin, and I'm getting 4.3 ohms, so that is your high power winding of the coil. And then I do black wire to white wire, and that is my my high resistance or hold power of the coil, and I'm getting about 151 ohms for that resistance. So that gives you an idea how to test a dual wound coil. Lastly, let's talk about AC voltage. And this is less commonly used, but it's mainly the input power that you're going to get for your pinball machine. So in this case, it's V with this wavy line, and at least in the US, you're going to have either 110 or 220 AC voltage going in. If you don't know what you have, just set it to the higher voltage limit. In this case, it's 500. So alternating current. So on your, at least on the US outlet, the bottom pin is your ground, and then let's see here. There we go. So then I have your hot and your neutral, and so I'll do I have 120 AC voltage for that. So that's how you can check if you got power going into the power supply in the back of your game, as well as your service outlet. Alright, that's it for the basics of how to use a multimeter and testing for pinball machines. If you have any questions, please drop me a line in the comment section of the video. Otherwise, thanks for watching. Please like and subscribe.